In 3.4, we're going to be talking about the distributive property, and I'm going to apologize in advance because I can't find my stylus, so I'm trying to write on the iPad with my finger, and hopefully you'll still be able to read it okay. One question we're really going to focus on this time is how do you use mental math to multiply two numbers? And we kind of talked about this in class the other day. Some people just do this naturally. Mr. Archibald happens to be one of those people. He just breaks numbers apart easily and he's able to multiply them, makes it easier. For me, I had to actually learn it as a way to do it, and now it makes a lot of sense. Hopefully, you'll feel that way too. The key idea here for the distributive property is to multiply a sum, remember that's a keyword for addition, or a difference, which is key for subtraction, by a number. You can multiply each number in the sum or the difference by the number outside the parentheses and then evaluate. And we're going to take a look at what that means in both number form and algebra form here in just a second. So in numbers, this is what it would possibly look like. If we had an expression like 3 times, and then we had some parentheses, 7 plus 2, to distribute, or to use the distributive property, we'd have to multiply 3 by both the 7 and the 2 that are inside the parentheses. So we would kind of rewrite it like this: 3 times 7 plus, because it was an addition in the first place, 3 times 2, and then to evaluate it, you would just figure out what each of those things mean. So 3 times 7, of course, is 21. 3 times 2 is 6. So 21 plus 6 is 27. So the final answer there would be 27, which is exactly what you would have gotten if you would have added your 7 and 2 together, which is 9, times 3, which is 27. And again, we're not abandoning order of operations here. You're going to see lots of examples in this chapter of why we would break a number apart to look like this and be able to use the distributive property. If we're looking at it from an algebraic expression, we could use something like A times, and then in parentheses, B plus C. And again, we would just distribute by multiplying the A by both parts of the parentheses, the B and the C, and so it would end up looking like A times B, and then you would add that to A times C. And again, in this case, you don't know what any of those numbers represent, so when you go to simplify it, you would just know that this would be A times B plus A times C as your final answer. And we couldn't get it any lower than that. And again, don't worry about it right now if that's not necessarily making a ton of sense, because we're going to see more examples. But just starting to look at what it looks like when you take something outside the parentheses and multiply it by everything inside the parentheses. For example 1, we're going to be using mental math. And I said this is one of those really good uses of the distributive property. And so we're going to try to solve 8 times 53 mentally instead of doing the long setup for multiplication. So if our original problem is 8 times 53, then this would be, whoops, see, told you I'm having a hard time with that without the stylus. So 8 times 53. This would be a good use to break something apart. We're going to break apart the 53 here and put that into parentheses, and then we'll use the distributive property. So 53 can be broken into numbers that are easier to multiply, like 50 plus 3, because that's what 53 equals. And then we can just use that distributive property, 8 times 50 and 8 times 3, and do that. Oops, I'm going to do that differently. So we've got the 8 times the 50. And we do have to make sure that we remember to use the addition, because that's what we did to break that 50 apart, or 53 apart. And then we would add that, and again, make sure you distribute the 8 to both numbers inside the parentheses. And then you just evaluate here by doing 8 times 50, which should be easy mental math because 8 times 5 is 40, and then you just stick the 0 on there. And then 8 times 3 we know is 24. And then all you have to do is add those numbers together, and 400 plus 24, of course, equals 424. And so even though I showed you all of the writing here. Technically, this could be done mentally if you know how to break that 53 apart into 50 plus 3, multiply each of those pieces by the number outside the parentheses, and then just add together your products for your final answer of 424. So again, we will start by showing everything in the beginning of this, and then eventually it'll become a wonderful mental math trick to use. For example 2, we're going to keep using the distributive property, but this time we're going to apply it to fractions. So this one again can be very useful. It just takes some good practice and making sure you're not forgetting everything we've learned about fractions so far. So here we're going to use the distributive property to find 1/2 times 2 3/4. And so this time we're going to start with our original problem, 1/2 times, 2 3/4, and we're going to break apart that 2 3/4 and put it in the parentheses, and that's the same thing as 2 plus 3/4. And now we can use the distributive property to find half of each of these items. Now, if you think about it, you're going to rewrite it anyway as 1/2 times 2 plus 1/2 times 3/4. And we're going to start by just focusing in on this first number. So if you needed to stick this over 1, you could, or if you just think of half of 2, we remember that half of 2 is equal to 1. And again, if you're looking just from a fraction standpoint, you could cross reduce these 2's out, make them into 1's, and then 1 over 1 times 1 over 1 would be the same thing as 1. But again, even if you weren't using all of your fraction steps, you could just ask yourself about 1/2 of 2, and you'll know half of 2 is just 1. And then we go to that next number, and this one's a little bit trickier because 1/2 of 3/4 is not something that everybody necessarily knows off the top of their head. But if you think about multiplication of fractions, you don't have to have common denominators. You just multiply numerators by denominators, and 1 times 3 is 3. And 2 times 4 is 8. And I didn't say it, but I should have mentioned, I did look both ways before I crossed there. I couldn't get these to go any lower, and I couldn't get those to go any lower, so then I just went ahead and multiplied those. And when we add those together, 1 plus 3/8, it's just 1 and 3/8. So again, it's a little bit easier to do it that way than if we had tried to turn this mixed number into an improper fraction. This one just is a different way to approach it. For these on your own problems, you're going to keep using that distributive property, and again, that is the key there. Make sure you are practicing the use of the distributive property. I know that you can do the long math to set up 41 times 5 and 9 times 19, but if you find yourself starting to set it up like this, then you are not using the distributive property, and you want to make sure that you go back to your notes and try to use the distributive property, because this isn't just about finding the answer, it's about finding the answer using the distributive property. Quick hint before you get too far on these on your own problems too. On number 2 here, 9 times 19, all the ones we've done so far we've broken into an addition, like 40 plus 1, but we hadn't tried yet a subtraction one, so you might want to consider making 19 something like 20 minus 1, because it makes it easier mental math. Just make sure that you remember to keep that subtraction going, and again, give it a try, and if you're not quite sure, then when the answers come up, really look at it and know that that's also an option. For example 3, we're going to start using the distributive property to help simplify algebraic expressions. So again, it's going to look a little bit different, but it will be one more step as we're starting to get used to this algebra piece. So if we start with letter A here, which was 4 times, and then in parentheses, n plus 5, to use that distributive property, remember we're going to multiply that 4 that's outside the parentheses by each of the pieces that's inside the parentheses. So we take 4 times n, and then we use addition because that's what's right here, and then we do 4 times 5, and remember we can't just stick the 5 next to it without a symbol because it'll look like 45. Over here it was fine because it just looks like 4 times n. And you really can't simplify 4 times n any farther, so it just becomes 4n, and then 4 times 5, of course, becomes 20, so our final simplified version of this expression would become 4 times n plus 20. For letter B, we start with the expression 12 times, then in parentheses 2y minus 3, and again, distributive property says multiply that 12 by each of these terms here. So we're going to do 12 times, and we do have to put this in parentheses or use another kind of multiplication symbol to make sure that we show that 2y is being multiplied. And then this time, make sure you remember to use the subtraction sign because that's what was up here, and you'll see why that becomes really important here. And then we're going to multiply the 12 again by the 3. And in this case, 12 times 2 is 24. So instead of 2y, we have 24y. And then 12 times 3 is 36. And you don't really have to worry about the fact that 36 is bigger than 24 because we're not going to subtract it at this point because 24y is different when it has a variable attached to it than just a constant. So we can't actually do any subtraction here. So our final answer here is 24y minus 36. For letter C, we're going to do the same thing, but this time you'll notice there are 3 terms inside the parentheses. There's 6 plus x plus 2, all being multiplied by 9. So the 9 is going to have to get multiplied by the 6 and become 9 times 6. And then we're going to have that addition, and we're going to multiply the 9 times the x. And again, that's another addition sign, and we're going to multiply that 9 by the 2. And so notice what I'm doing is I'm not actually writing what they equal right now. I'm just showing myself using that 9 each time being multiplied. And then we take it to the next step where we simplify. And 9 times 6 is 54. And then 9 times x can't really go any lower, so we just leave that as 9x. And then 9 times 2 is 18. And in this time, we're not actually technically done yet because we still have these like terms right here. And in order to get it as simplified as we can, we've got to get all like terms together. So if you think about all those properties we studied in 3.3, we can actually do some moving around because this is an addition problem. So we can use things like the associative and the commutative property. In this case, I'm just going to use the commutative property and move a couple things around. If I switch the order of these two things and make that 9x come first and then the 54 comes second and then just leave the 18 at the end, then you'll see a little bit more easily that those two constants, 54 plus 18, can be added together. So we kind of are using that associative property to group those two like things and do the side math if you need to, but 54 plus 18 is going to give me 72. So now it's as simplified as it can go, and that's our final answer. Here are a couple of on your own problems, and I'm going to really remind you on here, watch your signs, especially in this one, when you're solving them. So good luck with these, and then check for your answers and make sure all of your steps match.